guys, I'm Darian Stansel and I will be showing you the bucket demo today. So right now I am running a conventional bucket. As you can see here, I'm doing a fill only part and this has a lot of defects. We are actually flashing at parting line, if you can see here. So if you come to my screen over here, this blue curve is our melt pressure that we are pulling from the front of the nozzle with the melt pressure transducer. When I'm running conventional, I'm hitting roughly 24,000 PSI. So that amount of pressure is actually blowing apart the mold at parting line, and so that's why we're seeing that parting line flash before we're actually filling out the part. I'm running this bucket in a 450 ton press right now, and it would probably normally be ran in a 600 ton press. Another thing to look at, I'm running this at 5 inches per second. And then if you look at our iMFLUX screen here, this purple curve is our screw velocity. So as you can see, this press is going up to that 5 inches per second, and it's maintaining that 5 inches per second, and it doesn't care that that amount of velocity is actually blowing apart the mold. Now I'm gonna go ahead and switch over to iMFLUX, and we're gonna make an iMFLUX full part. The only thing that I'm going to change when I do this is I'm gonna take my transfer position from 1.5, and I'm gonna take it to 0.5. And then up here, I'm going to go ahead and enable iMFLUX. I'm going to be running at 16,800 PSI. So as you can see, we're going up to the set pressure and we're maintaining it throughout the process, whereas you saw the varying pressure with the conventional process. One thing to look at here is that I showed you the velocity earlier. Well, on this part, you can see the velocity is obviously much different. With iMFLUX, the part geometry is actually dictating the velocity that you see. So the initial spike in velocity that you see is actually where we are filling out the bucket on the bottom here. So as we're filling out, it fills very easily. And so that's why you see that initial spike. Where you see this rapid decrease here is where we're hitting the edge of the bucket. So if it maintained that velocity, your pressure would skyrocket. So when it hits this is when you see that drop in velocity. As you go ahead and fill out the rest of the sidewall of the part, you're going to see this little bit of a blip up here, and then as you fill out the rest of the part, your velocity is going to slowly back off. So we'll go ahead and pull this back up. So here is your iMFLUX full part. I molded this at, my set point was 16,800. I was roughly 17,000 max pressure. So that's about a 7,000 pressure reduction. And because of that pressure reduction is why we're able to fill this part out without flashing here at the parting line like you were seeing earlier on the conventional parts. Now I'm going to go ahead and I'm going to run an iMFLUX short shot so that you can compare the short shot versus the conventional short shot. So all I'm going to do that is I'm just going to lower my pressure here and we will run a short shot that's comparable to the conventional. Another thing to look at when you're running iMFLUX is if you see here your screw position, this dark blue line here is very not as linear as you would see with a conventional screw position. So you don't see that bounce at the end where we transfer, you don't see that. So we'll grab this for a visual. So here is the difference between an iMFLUX short shot that I have here and a conventional short shot that you saw before. As you can see, we're not flashing here at parting line and we are packing as we fill. So you do not have all of the defects that you see in the conventional part. So. All right, well, thank you for watching the demo. Thank you.